Hello? It's me? Oh, happy Halloween! Look, there's my Batman chair with the Halloween teddy bear. Woo! So we've been working on adding subtracting rationals, day one. And just kind of, we did a pretty good video on the front there. We did some of these in class. Here's our steps. Get a common denominator. Distribute the negative, combine the top over the bottom once, and reduce it. Watch out for the negatives, right? Don't forget the negatives. So you need to make sure, like for 6, for example, you need to make sure to distribute the negative through. So the negative goes with the x and the 5. So be careful there. So we get x plus 1 minus x minus 5 all over 12x, right? And then you have, you can group those together. So we have our x terms, we have x minus x, and then we have our constants, 1, 1, and negative 5. All over the denominator once. Some of you are doing like 12 plus 12, and that's wrong. It's just the denominator. The denominator. I'll be back. So just the denominator, denominator, how do you spell denominator? Denominator. That's all right. So anyways, the denominator, sorry. So the denominator once. Denominator once. Cool. That's bad spelling. Okay, so then x minus x is just 0x, which anything named 0 just goes away. And then negative 5 with a positive 1 is negative 4 over 12x. And then we divide by 4, divide by 4. Don't forget to step number 4, reduce it. So we get a negative 1/3 x. Because 12 divided by 4 is 3. Cool. Number 8, you're going to multiply by x squared. If you do it to the bottom, you have to do it to the top. Right? Right. Because then you have a common denominator, 5x squared, 5x squared. So we get x plus 4 plus 3x to the 1, 2, 3, third power all over 5x squared. And then 3x to the third power plus x, because you want to put the highest power first. The highest power first. Okay, let's up to the back side. Okay, ooh, scary number 16. Is it scary, man? Is that Halloween? So we want to get a common denominator with all 3 of them. Well, this has an x cubed, so this one's like sad. Well, I need an x. Okay, well here, have an x. Don't be sad. And if you do it to the bottom, you have to do it to the top. Multiply x to the bottom, multiply x to the top. That means multiply. Multiply. Good. Now they're happy. Oh, but I want an x too, but I need double that. I need x squared. Okay, here, fine. Merry Christmas, Happy Halloween. There's your candy, x squared. So now look, they all have an x cubed, and they're all so happy because you're a 2x cubed now, and you're a 2x cubed now, and you're just a sad x cubed. What do you want? To be like the others, huh? Just be yourself. Oh, you need to be common so we can combine you all together? Okay, well, we'll give you a 2 then. And if we multiply you a 2, if we do to the bottom, we also have to do to the top. So there we go. So on the top, we have 1 times x squared is x squared, all over 2x cubed, good, plus 1 times x is just x, over 2x cubed, common denominator, minus 2 times 1 is 2, all over 2x cubed. So we are going to combine the top over the bottom just once. That means x squared plus x minus 2, all over 2x cubed just once. Remember, when you're adding fractions, you're just going to combine the top and the bottom once. For example, 1 6 plus 2 6 plus 3 6. Well, another 2 6. Okay. What's that? Well, that's 1 plus 2 plus 2, 6. See? See? Combine the top or the bottom once. Right? Because 1 6 plus 2 6 is 3 6 plus another 2 is 5 6. So it is 5 6. But we want to write it like that because we're dealing with x's. We're dealing with variables. So that was just an example. Just an example, but it was a good example. Why'd you cross it out then? Okay, sorry. So that was just like a good example, just like off to the side. Just an example, off to the side. Okay, cool. So let's go to a review one. Ooh, what the? That's not right. We're not doing graphing. What are we actually doing? Oh, we're multiplying and dividing rational equations. So 17 and 18, we changed up this year. We did different order of things. So we're not doing graphing yet. Hold on, not doing graphing yet. I know the other video had graphing on there. So I'm just going to pause this for a second. Still doing good, Mr. Pumpkin Teddy Bear. All right, I found it. So after these ones, we're not doing yet. Waiting until next unit there. Here we go, reviewing. So we're going to be reviewing, so we're going to be factoring and canceling stuff out. So don't forget the division, you're going to become multiplication. Remember, it's keep, change, flip, right? Keep, change, flip, A-N-G. So keep, change, flip, and factor. Don't forget to factor, lots of factoring. Canceling stuff out, listing your exclusions. Cool. And so this will become what? X squared plus 3x minus 88 in the top. And then the bottom is x squared minus 6x minus 27. And so that's going to factor into what? 9 and 3. Then the sign in the middle term, negative, goes with a bigger number. Good. And then is that 11 and 8? I think it's 11 and 8. Good. And then 11 and 8 with a bigger 11 and a smaller 8. And so you also need to factor these ones. So I'll let you finish factoring these ones. I'm guessing probably 10 and 3, right? And then 22 could be what, like 2 and 11 probably. So we'll finish those. For this one, you got a little stuck there, didn't you? So this one is called single factoring. Oh, single A's. Remember single factoring? Single factoring. There we go. So then we're going to divide by x. Divide, they both have x in common. So divide by x, multiply by x, right? Yeah, whoa. So that's going to be single factoring. So divide by x, multiply by x is called single factoring. So x squared, take away one of the x's, leaves us with an x. X's cancel, leaving us with a 12. Up here, you're going to pull out an x, And when you do that, x squared take away an x is just an x, and then x over x becomes a 1. Keep on factoring. Every day we're factoring. 1, 1, 1, 1, 1, 1. 1, 1, 1, 1, 1. So what we're going to do is factor. What are factors of 36? 6 times 6 is 36? Tricky. We needed to add up to 9. Add up to 9. That's a tough one. I know the bottom one is what? 7 times 3 is 21. Negative times a negative is a positive. What are factors of 36? You better list them all. Okay. So here we go. So we have 1 times 36, 2 times 18, 3 times 12, when you subtract it, is 9. I think that's it. And then the sign in the middle term goes with a bigger number. There we go. Look at that. Nice, nice. So now we're going to cancel stuff out. And so x divided by x becomes a 1, goes away. X minus 3 goes away. And x plus 12 go away. Wow. So it reduces all the way down to x plus 1 and x plus 1 divided by x minus 7 is our answer. Don't know if you need the parentheses or not. And if we were going to list all the exclusions, which I don't know if we did on this one, but we should have done with you. If we're going to list all the exclusions, I would probably list them all by saying x can't equal a 0 from that single x. And x can't equal -12, and 7, and 3. So that would be all these exclusions for that particular problem. Okay, last but not least, we're going to do a word problem. ACT review that's coming up, you guys, at the beginning of next year, March, April. February, March, April next year. Okay, so what fraction lies exactly between 2/3 and 3/4? I mean, if it was me, I'd probably turn all these into like decimals and just convert each one to a decimal. Like, honestly, if I was doing this on the ACTs, it wouldn't take too long. Because I already have that this is like 0.66 repeating. Don't be superstitious. And this one's like 0.75, right? And 3/4, 0.75. So we're looking for a fraction that lies between those. So then you can just try each one. How about 3/5? No, too small. What about 5/6? No, too big. What about 17/24, the very last one? Bingo, bango, bongo. 0.708. 0.708 is in between these two, right? Bam. And then we have 750 piece jigsaw puzzle, and they include 5 extra pieces, along with 750 pieces. So that's 755 pieces. What's the probability that we'd be drawing a piece randomly? We break it down the box and only select one piece at random. What's the probability it'd be one of those extra pieces? Well, there's 5 extra pieces out of 755 total pieces. Woo! Nice, nice. Okay, so thanks to you behind the screen. Thanks for watching. Did you notice I added some more jack-lanterns? I also added this for Halloween this year. Woo! Witch cackle. Hi, thanks for watching. Happy Halloween, thanks for watching. Peace out, and bye for now.